Thank you. You are the smart people. It's so good to be here. This is my favorite. Every year I look forward to coming here, and this is the best. And last year I was here with my friend Zach Smith, Hoken, and he was giving a talk about RepRap, and I was giving a talk about DIY manufacturing stuff. And we had planned, we were like, let's figure something out at 25C3. Let's like put this together and make it happen. And then of course we just drank the whole time and had a really great time. And we didn't really figure it out till we got back. And we got back and we thought, let's just nail this 3D printing thing. So many cases of ramen, and we actually started importing Club Mate. So it wouldn't have happened without that, and we started this company called MakerBot Industries. And what you see there is the Cupcake CNC. It's a 3D printer that makes things about this size. And today I'm actually going to talk a little bit about that because that's what I've been obsessed with, but I'm also going to talk about this idea of frontiers. I started noticing this when people would come up to me and they'd say, hey, this looks really cool. Can I make PCBs out of it? And I'd be like, nobody's done that yet. That could be yours. And there's all these kind of things that people would just come up to me and be like, well, can it do this? Dan Kaminsky came up to me and he's like, can we make a chicken out of chicken? So that's going to be disgusting, by the way. And there's this kind of idea that it's a really amazing time right now in hardware where things are modular, they're becoming more and more open, and the possibilities for doing awesome things just keep becoming more and more. There's more opportunities to do this kind of thing. So, disclaimer, this is just going to be, I'm going to be talking about things that I think are really exciting, and you may have different things about what kind of the exciting frontiers right now, and if you do, go ahead and Twitter them using the hashtag Frontier. And so my idea here is, there's so many people who there's not so many people. There's some people who have time and they watch TV. And so just stop that and you'll have more time to do things. And or just maybe you have just some time, or you have a job that keeps you busy, but you have a weekend every once in a while. So the kind of thing I'm thinking about is maybe you have some spare cycles to dedicate to a badass project. So the one that we basically dedicated our time to this last year was 3D printing. So I'm going to talk a little bit about that, and then a bunch about some other stuff that I'm excited about. So this is the machine. It works, which is really great. And the idea is basically you can design and download things and then print them out, and then you have them. And you didn't have to necessarily pay for the designs. You had to pay for some plastic. And it's very great for customizing things. So if you have, if your dishwasher knob breaks, you can go ahead and they're really hard. You can't even buy those things. So you can just measure it and make a new one. And it builds it up layer by layer. So the plastic goes in and it gets heated up and then it draws a picture. So if it's drawing a cup, it'll draw a circle and then it'll fill in the bottom one, and then lots of other circles to make the side of the cup. Or dragons. Yeah, this was a model that was available, that was open on the internet. It was a full dragon. I had to chop its head off. This is Dominic Muir, and I met him, and he introduced himself, and he says, I'm the guy who took who got my head scanned, and I managed to get the data, and there's a program you can use to choose what density of the data of your, I think it's an MRI kind of scan. And he selected his skull. So, good replacement part. And I was like, okay, we're printing that now. And it looks really cool. I went to Noisebridge to check in on their MakerBot recently, and we got it working, and they promptly just started printing out skulls like crazy, and their MakerBot has skulls all over it. Will Langford is a guy who goes to Tufts University, and he has a MakerBot on his mini fridge, and he's decided that 13/16 of a teaspoon is really the best teaspoon measurement. I mean, really he should just go metric, but yeah, metric always gets you. I love metric. That's the other thing we did. We're trying to convert the United States to the true path of metric. So the machine is metric whenever we can. Yeah. Base 10. Oh, this is a whistle. So this is Zago. He's in the audience here somewhere. He's a designer, and he made this whistle. Where is he? There he is. And yeah. And the cool thing, I mean, it's a cool whistle, and it actually prints a little ball out inside when you print it out, which is cool. But the thing that I really like about it is he did this design, and he published it on Thingiverse, which is a site that we made for sharing objects. And within half an hour, I'd printed out one, and then I went to share my picture of it, and like tons of other people, it's been already printed out whistles within half an hour of it being on the internet. So this is about as close as you can get to teleportation right now. To get a whistle from Germany to New York, you'd have to put it on a missile. And a whistle on a missile, it's just going to get ugly. This is Adam's a ring that he made. He was going to Iceland the next day and decided he was going to pop a question. And so he just maker-botted a ring. And she said yes. So it prints love. So there's this whole idea of sharing. We're basically obsessed with this. Everything I do, I share as much as possible. Sometimes it sucks, and I hope that the people if people are interested in the kind of thing that I did, that they take it farther. And we're doing this basically, it's open source hardware. So everything we're doing is, you can even go to our svn.makerbot.com and download all the stuff that doesn't even work yet. And so it's all open. We share everything, the circuit boards, the DXF files for the laser cutter, whole 9 yards. So the cool thing is, when somebody gets a MakerBot, let's say they want to do something different with it, they can just do it, and then they can reshare it, and everybody benefits. So we have the site where people share these things, which makes it really easy. This was like, Zach and I were like, let's do this site. We have an hour. And we had this thing called Saturday Spaz, where we're trying to do a project that's different from what we're normally doing in an hour. And at the end of the hour, we're like, this is pretty good. Let's do another hour. So we share all of our junk on Thingiverse. And we eventually needed an inventory management system. So Zach actually incorporated it into Thingiverse, and then we made it so everybody can have an inventory management system. So don't ever pay money for an inventory management system when you start your manufacturing business. This is our GitHub repository, and the thing that I like is, even though you see lots of Hoken and Fuki, that's Adam and Zach, there's also there's Eberhard right there. He's support for heated build platform new machine. Everybody's obsessed with heated build platforms right now, and he's got one of those and shared the work. This is the next version of electronics. I think this is the schematic for it. We're actually building it on the Arduino Mega, which is another open source project, and then we're just adding tons of junk on there to make it work for what we're doing. The community is kind of obsessed. This whole heated build platform makes it so that things don't warp as much, and so they're making them and selling them, and we're just trying to keep up. We have these little parts on here that are plastic that work as pulleys. And when we originally shipped it, we shipped it with laser cut parts, and it was really, really thin, and you had to glue it and wait overnight. And so we actually started getting people who have MakerBots to make parts for more MakerBots, which is cool. And so here's the story. So this is a plastic extruder. This is the Mark IV. It's a little fussy to build. This is probably the hardest part of it to build, because it comes as a kit. And it's way better than the Mark II, though. Like, the Mark II is really frustrating. But so Nate True, who's one of the guys who worked on breaking the iPhone, got one of these, and he's like, I'm going to make this better. Dad, come over. And his dad came over, and they totally they were having some issues with something. One of the thing's expanding, so they put those little clamps on it. And then he shared it, and now everybody can do this. And we took one of these things, he's got a nut on there that holds it on, and now everybody gets that nut. It's also cool, so this is just another story of how the whole thing, community development kind of works. We had, for temperature, you have to heat it up to 220 degrees and then feed the plastic in. And we were basically banging the temperature between 215 and 225 Celsius to keep it around 220. It would just go bounce between them. And Tim Myrtle was like, this sucks. And he just jacked that part out of the code, implemented PID, which basically means when you turn it on now, it just goes, and it's like 220. There's an obsessive community that talks about this, and you're welcome to join. It can be a little chatty sometimes, but it's fun. So that's MakerBot, that's the frontier, and the idea is, this is the first part of my talk. I'm inviting you if you want to get into it. There's actually 3 downstairs if you're desperate or excited. And you're invited to join in this kind of frontier. The goal is basically to make it so you don't have to go to the store anymore. I mean, if you can make something in less time, if you can print something out in less time than it takes you to go to the store, then you've saved all that transportation cost from China or wherever it is the thing was made. Hopefully, yeah. And so, yeah, you're invited. Another thing that I'm getting excited about is this idea of an open CNC mill. And there's actually a bunch of projects like this, and there's a lot of actually open CNC mill stuff. And with EMC squared, which is a Linux-based controller, it really should be a lot easier than it is. So this is generally kind of what they look like if you do it yourself. And then this is one that the MIT folks are working on. That it looks kind of similar to another machine. And I like this, but it uses a router. I want to do a version of this that uses like laser cut parts, because I don't have a router yet. And here's, so Roboteer Nat is one of the guys who didn't buy it from us. He just downloaded all the designs and made it himself. Like he swore a lot on Twitter as he did it too. And it was kind of like, okay, yeah, that's because he's doing, he's doing it all from scratch, which is kind of intense, and it took us a long time to figure it out. And then at some point he was like, I need more electronics, and they aren't in the store yet because we had ordered them and they hadn't come in. And so he just figured out a way to convert his machine to make circuit boards, which is awesome. And if you're into open mills, I just started this group basically because I think there needs to be more kind of discussion about trying to get something that, ideally like something that like 500 people can have and develop on. Right now there's all the DIY CNC mills, there's not like a lot of, not everybody has, they're all really different. Next frontier that I'm obsessed with is frosting. So we had this problem, this is the Mark I. When we made it, we called it the cupcake because we thought, okay, well, it's going to make things about the size of a cupcake. And I'm like, yeah, and we're going to make it frost cupcakes. So we had to sort of deliver on that. This is the first one, and it's actually using a syringe, and then there's a push rod that's pushing the syringe in. So whatever you put in the syringe, frosting, gets pushed out the end. And it turns out that this is a horrible way to do it. And we battled with it for like months. And then we were like, okay, we ended up going to this hack day thing and not sleeping for 36 hours, which turns out to be one of the best ways to get things done. And even though you can't see it, this is a second mention of Dan Kaminsky. That's him, really blurry, pumping it up. And we made it so it would download the news and print it out on toast. Or, yeah. Yeah, and the weather. And the cool thing is that even though this isn't, even though we had a lot of fun with peanut butter, and now the frontier of completely liquefied chicken is open. There's other possibilities like UV curable silicone, and we're actually going to get a kiln because we just figured out that we can put clay in this thing and make like teacups and stuff out of clay and then fire them. Very old technology, but made with a robot. So, I mean, what would you stick into a Frostruder? Like, we've done jam and peanut butter and frosting and fluffernutter. Bad idea. And So, next one that I'm excited about is an open scanner. So, how many of you would like a copy of your head? You know? You can just do revisions. You can be like, okay, I'm going back to revision, age 27. I want that. This is one way to do it, of course, with Legos. And this is a little poker. You can't see it very well, but that little green thing is a little frog that looks like this. And this contraption pokes the frog and measures, the amount that it poked to make a point cloud. This doesn't work so well on your face. And this is, I have to do this anyway. Put someone in a bathtub, and you just start filling it up with ink, which just gotta get you dirty. And then you take a picture every time it comes up a little bit, and that gives you a bunch of, it's fun, it seems like. This is another thing. I saw this. Bathsheba. Feel free to interrupt me at any time, but you should probably use the. Did somebody have a question? Did I say something? All right. So this is Bathsheba Grossman. I saw this picture of her. She's a badass. You can go to bathsheba.com, and she makes these amazing sculptures. And she's been doing it for ever. She's a major pioneer. And I was like, what the heck is that in the background? And it took me an hour or two of internet looking, and it's a microscribe. And what this is a bunch of, my guess is it's a servo with encoders on it, and then there's math that figures out, okay, if I touch it here and here and here and here and push the button each time it touches, that will set a point there. And even though it's an arm and not a Cartesian coordinate, there's some math involved. Yeah, I want one of those. So that's that's probably more than a weekend, maybe 2 weekends, to make something that doesn't work very well that looks like that. But I want it. There's a David scanner. This is a laser scanner. This is really awesome. It's not open, unfortunately. There's a crippled version that you can download for free. And you can see I got this thing I got at the corner store that's actually for holding dragons and knights. And I then copied it, but you can see the resolution's kind of low because it's the free version. This same kind of thing can be done. Zignig thought about this, and he made this printable part system where you print out all the parts, and then you have a turntable, and these little shelves are for the laser line and the webcam. And so the way this works is you can't scan with a laser. The way it works is you can scan with a laser. You take the laser line, and then if it was my head, you'd run it across it, and it would be at a different angle than the webcam. So it would make from the webcam's perspective, it would make an interesting line, which then becomes a line of points, and then you end up with the front of my face, and then of course I turn to the side so you can get this ear, and it goes, and you get all the data that way. And the software is the hard part of this. The hardware is basically, you just buy a laser off Deal Extreme, and you have a webcam on your computer probably. And then you import it into a program called MeshLab, which is open source. Yes? Oh, I'm not done, but which one is it? Oh, yeah. The video beamer one where you have a grid or a number of different things, and then it... Yeah. So the idea is, I don't have that one on here, and did you work on that project? Oh, cool. Let's talk afterwards. What's it called? Cool. I want to play with that. Okay, yeah, that's cool. Anyway, then you use this program called MeshLab, which is really awesome, which takes a bunch of meshes and lets you put them together. It's got a little bit of a learning curve, but when you're desperate enough, you'll figure it out. It's pretty. Some friends, Andy and Dan Barry, have started this little project where they're using a galvanometer to move the laser line, and that's a shoe. You can check that out. I want to scan my head. I want to scan, when I need a replacement part, I want to just be able to put it in, scan it, print out a new one. This is like the replicator idea, like tea, Earl Grey hot, and and then it gets interesting when you start, what do you have that at this point, to copy it, you need, what do you have that's this big or smaller that you would want to just copy? Or you could scale it. You could scan your car and make it this big. So there's a scanner group. Everybody argues about which one's the best, and I'm hoping to see more like things happen here. This is just a stupid project I did that I think is cool. I was like, I don't need a watch, I'll make one. So it's a watch that has lots of LEDs, and it's an Arduino platform, so you could put modular components. You could put a breathalyzer on it and be like, and it'd be like, okay, yeah, I can't drive. This is one that I'm recently excited about. This is a place nearby called Raumgart Agentur, which is space station, and they're a hackerspace nearby. And they're making electric bikes that have this motor in them. And basically, it's not a bicycle and it's not a motorcycle, but it's something awesome in between. And I really want one now. And interestingly enough, MIT just came out, talked about this Copenhagen wheel, which is basically what they're doing, but the Copenhagen wheel, they're adding like, they want to be able to control it with your iPod, and I think it's mostly, I'd like to see one, but I like that. Wow, I'm really going really quick here. So this is a frontier that I'm excited about that isn't like a hardware frontier, and this is this whole thing that we're doing. Well, first of all, how many of you have ever contributed to an open source project in some way? I'm just kind of curious. Okay, yes. That was really cool. That's wow, that just gave me the shivers. Because what that means is like, this community especially is capable of doing stuff and sharing it. Like, this is probably one of the most powerful sharing communities in this room and the people watching this stream. And this idea that, we used to have to go to school, and we don't have to anymore. You can, you can make friends there, and you can be inspired by teachers, and it's great. But this thing that's happening where we're sharing means that we're like, it's going to be a different future. These kids we were at the Maker Faire, which is a thing that happens in San Francisco where people who make things get together and they share their projects. And they're all, like, I didn't set this up or anything. I was just like, okay, kids, I'm taking a picture. But I really like the idea that these young people might be around adults who are making things instead of buying them. And now a lot of our culture is focused on, oh, I want something. Where am I going to go shopping for that? And I really like the idea that maybe young people in the future, let's just say it's going to happen. In the future, young people like this will think, okay, maybe instead of buying it, I'll just print one out, or I'll just make one. Or let me see if there's an open source project for that first. And that gets me, to me, that's the most exciting thing that's one of the more exciting things that I get excited about with open source projects, software and hardware. So, yeah, I feel like I'm preaching to converted here, but. So I'm curious, because this is just a few of the cycles, the frontiers that I'm interested in. And I'm curious, what are the frontiers maybe that you're already working on? Let's just Twitter that if you have something that you're working on or that you're excited about or that you think more people should be putting spare cycles into. Because if just this room, if there was just if each of us took a day out of the year and use those spare cycles for a project that would, develop infrastructure with a community, it gets really interesting. And I think in some ways we already do that, but it's not like I don't know about all of these things. So I invite you to do that. I'm happy to talk. I've got a little bit more time. and I would be happy to take lots of questions. I wanted to get done kind of quickly so I could take any questions. So if you've got questions.
Okay, for the people who do have questions, please walk to the microphone. There are 2 of them. They're in the middle of the aisles, and ask anything you'd like.
Yeah. Thank you.
In case you've seen any of these augmented reality applications on Android and iPhone and whatnot, it basically it's a camera, a video camera, and a directional sensor. So for large objects, maybe you could just walk around the object and record both the video and the direction, and then just recompute the shape from that.
There's actually a guy whose name is, I believe, QI, his first name, and he's just done like a PhD or a dissertation or something on this project, and I should have put that up here actually. And he uses a webcam and turns the object around in front of it, and it kind of takes a picture and maps it. It looks, I haven't seen any, like as far as I know, it's just been like, here's a screenshot. And I don't know exactly if it's open or how available it is, but I think that's that's definitely another possibility for scanning things. And yeah, that sounds like a good trail to blaze.
Okay.
Over here.
Hello, Bree. My name is Neuner. I'm from the hackerspace in Munich, the Capsule. We have had a rep for half a year now, and I wanted to ask you, what software do you use to model or to create your objects in CAD, because all the open software we have tried until now is really horrible compared to professional software or commercial software.
You know, there's a new program that everybody's excited about called OpenSCAD, OpenSCAD, and that's for actually programming 3D objects. And people are getting, I don't think it's not for like drawing dragons, but or modeling dragons, but that's one thing that people are excited about. Blender's about to come out with the new version 2.5, and I'm super excited for that. Are there people in here who are working on that project? Hells yeah, awesome.
Thank you.
So, but to answer your question, why isn't, there are a few programs like AutoCAD, and Inventor is another one. And they are easier to use. And one of the things that, and I could, this might just be my experience, but one of the things that I would love to see more types of people get, like I would like to see more UI designers obsessed with open source. I think that would make things. And I say that because I feel like the open source, especially with Blender, and I think the next version's actually going to, I looked at it the other day, and it looks really awesome, and it looks like it solves, like I can kind of use it, I can use it now, but it took a long time, so it looks like it's going to be easier. He says there's still a lot missing. Good. That means there's stuff to do still that you can all do, or we can all do together. Next question. Is there another one over here?
Okay, hello, I'm Richard from C3 and Hackerspace in Luxembourg. I would like to ask about this, about your machine there. What's the tolerances? How precise can you move, like a tenth of a millimeter? And also, can you adjust sort of like how thin this plastic is coming out or how thick it comes out?
That's a good question. So the question was how accurate it is and what's the layer height, basically. Those are the two. You have the resolution, which is how thick the spaghetti comes out. And that's actually about a third of a millimeter. It depends on your exact nozzle, but I set mine at 0.375. It's actually a 0.5 millimeter nozzle, but when it comes out, if you move that faster, it stretches it a little bit. And if you want, depending on the tolerances you can get on your machine, because some people, depending on how fussy you want to be with it, some people have been able to get it down to like 0.25, 0.3 of a millimeter in terms of layer height. So that's kind of your resolution. That's how thick something's going to be. In terms of how accurate it is, you're really close with a tenth of a millimeter. It's actually 0.08 of a millimeter. So which is about in for the people in other lands, that's about 300 DPI.
Just the nozzle there that's fixed, I mean, during construction, you cannot sort of change it in the middle, huh?
We've talked about having a nozzle that has like, what is that called on a camera where it opens and closes? An iris. But when you're talking about things at 220 degrees Celsius, and it's hard, actually. So, and it's possible, but as you add on something like that, it gets a lot more expensive. So there's a bunch of people who are messing around with different nozzle types, changing the nozzle head during a print. Well, we're working on an extruder with 2 nozzles that you'll just be able to upgrade, and we made everything so it's super like future compatible. So you'll just jack it out and put the new one in if you ever want to get one. And that way you can print support material, and you could even have 2 different types of nozzles on there.
Okay, thank you.
Thank you.
These are a few of the examples you made.
Yeah, I made this. This was made at Studio 70, which is a hack lab in town, which is really cool. Is the person who made this here? It was left on the table with Philip, and it's really cool. It's a Tintin's rocket. This is actually made with multiple printed, like he did this in, I think there's like 6 pieces here, a different one for the fin and that, and the 2 parts for this. So this is actually bigger than the build size, but he did it by combining things.
Yeah, and I also like the technique to use the head, because you cannot print it like this, I've heard.
Oh yeah. Oh, I printed upside down, because otherwise the nose has a little bit of overhang. He gets boogers. This is Unfold, is his handle, and he's in Brussels. Here, why don't we pass this around, and you can that just kind of gives you an idea. I took the top and the bottom off so you could kind of see what it looks like on the inside. It's totally hollow. It's not very strong because I just made it really, I was kind of in a hurry. And if you make it so that doesn't have a lot of infill, it goes faster, because otherwise it has to do all the infill. Yes, sir.
Yeah, firstly, just congratulations on MakerBot. It's a really exciting project, and it's good to see you building a company around it and selling some stuff. So yeah, first off, well done.
Thank you.
2, I hear people are playing with heated build platforms, and I've seen in a couple of industrial machines there are whole heated build chambers. And I understand Adrian Bowyer did a little playing around with that, and I think it helps and stuff. I mean, I'm not an expert, but is that something you're going to look at, and do you understand how it helps?
The question is basically like, why don't you just enclose it all and then heat it up on the inside? And I've been thinking about that too. It actually would be really easy to hack just to add doors and hinges, and like a record player mount, like one of those, that would look cool. But somebody tried this on the group, and my memory is not so good about it, but they basically ranted about how they thought it would work, and it didn't work, even though and so what everybody's really excited about is this heated build platform, because with ABS it shrinks about 1 or 2%. And so if you make something that's 100 millimeters long, it's going to shrink a millimeter, and that has to come from somewhere. So it curls up as you're printing, and the cooling happens. So everybody's, like, people are, like, the heated build base is what everybody, like, it works and everybody's loving it. So we're trying to figure out a way to get that in production.
Okay, cool. But presumably as you grow tool structures that are not so heat conductive near the top, shrinkage, I guess, is still an issue. So if you print maybe a cylinder, it's going to end up a cone. I don't know.
Yeah, another thing that people have done is that they've actually cooled it down. They put a fan on there, and there's actually a G code that is built in that you can turn the fan on and off wherever you want. And because then it cools down really fast. The downside of this is it gets brittle. It's because it doesn't adhere as well. But the cool thing is that you can do bigger overhangs, because instead of, if this is, a third of a millimeter, and you put one down kind of on diagonal, if you put it too far of an overhang, it'll just fall off. But if you cool it down right away, you can actually get a little bit more of an overhang out of it.
Cool, cheers.
So temperature control is, it's cool. Over here, yeah.
Okay, an idea just popped in my mind, and now I really want it. I think, why don't hack liquids or chemicals in general? Like,
Can you say that again? Why don't we hack what?
liquids,
Liquids.
or chemicals. Like just open source, don't know, liquid mixer or something that has some stuff in it, and you can, yeah, and open Jägermeister.
Yeah. I mean, with the syringe, we're getting there. We're moving in that direction. And, but I like this idea of being able to, I'm not exactly sure, are you wanting to take, I'm not sure I understand, you want to take like epoxy and mix it on the fly? Is that what you're talking about?
Yeah, I don't know. I just thought of some things where some wires for liquid, pipes, yes, go in, and there's some pump and the swirls and something like this.
Yes. I'm not exactly sure what it is, but let's talk afterwards, because if you want it, and it has liquid involved, it sounds, I'm in. Yes.
Hello, my name is Barcode. I'm from the Beijing Linux user group. I have a question about the material as well. At the moment it's ABS, and is that easily available, or is that even possible to produce that yourself in some kind, or are there any alternatives which are usable in the same way?
So the question is about materials. Right now you can print with ABS, which is the same thing Lego is made out of. And you can print out with HDPE, which is, it's like they actually in the States use it in milk jugs. I'm not sure if you use that. I haven't seen those in the store here, but it's like a plastic. It's got a really great friction coefficient, so it's very slippery. And, but it shrinks a little bit more, so it's a little bit of a problem. And what we're really excited about is we just did our final prototype of material called PLA, which is polylactic acid, which is made from corn. And it smells like French fries when you're making things with it. And it's clear, so it's like begging for LEDs. And it's the way it works is plastic and these type of things are sold as pellets. And ideally what would be really cool is if we could make a pellet extruder, but we've thought about it quite a bit, and doing it with off-the-shelf parts, we haven't got our head around that yet. In theory it's possible. But it's actually pretty straightforward to feed a filament in and then melt that. So that's what we ended up doing is we ended up buying these pellets, having it shipped to a place in Ohio that has a machine that's about the size of a room. And they take the pellets and they turn it into that, and then they ship it to us. And the cool thing is that it's not that expensive. It's $10 a pound for white ABS and $12 for black, and we haven't actually gotten the bill on the PLA yet, so I don't know how much that's going to cost yet. But we have ordered 1,000 pounds of it. We had, it's really exciting. It's really cool material.
So it's all easily available?
It's easily available. I would like it if like right now, it's interesting. Like I've had to learn how to ship things. Use this mail device, and the whole shipping thing is we've solved that this year, but it was really tricky to figure that all out and make everything go to the right place at the right time and get through customs and all that.
Okay, thank you.
Thank you.
My question is again about materials.
Yes.
Again, liquids, but another approach. There are plastics which come in liquid form and harden out if they are exposed to ultraviolet light. And ultraviolet LEDs have become really cheap at very good output powers. So my idea was put that LED at the place where the extruder is, a small focusing lens so that you have a really bright spot, and then move the LED above the surface of the liquid and sink the platform into the liquid down so that you are printing in layers the liquid solidifying on the outer rim hull.
So this is, yes. The cool thing is like, yes, that's yes. I want to do that, but I'm having to ship boxes right now, so I don't have as much time as I want to do it. So one of the cool things is you or a group of friends, it's more fun to do this with friends, it can figure this out. And you could just buy LEDs, you could buy a containment device. You would have to probably hack our machine to make it so that it would make because right now we have the extruder going up and down. So you would want to kind of flip it over so the tub of UV curable, I know about UV curable silicone, which I'm excited about because we can extrude that with the extruder. But I like this tub idea, and if you do it, you're that guy who did it. And I want to talk later about the other stuff too. Yes, sir.
Okay, I have a question. Have you tried using this material, what comes out of the extruder and the model, as a stabilizing matrix for other materials, so you can alter the physical was heißt denn? Scheiße, Mann. Eigenschaften. Yeah, the physical properties of the models you built?
You know, I met Ben yesterday. I'm not sure if it was at Seabase or downstairs, and he's I'm not getting this right, but some sort of chemical engineer or materials engineer. I'm not a materials engineer, but yes. The cool thing is, it's the way that these things get done, even in labs and wherever, is people just try things and do it wrong as many times as it takes. And so, yeah.
Okay, cool.
Hello.
Thank you. We can talk more about it later too if you want.
Okay.
Hi, I would like to know about the strength of the result. Could you do a knob for the washing machine or something like that? Or is it more for decoration?
Well, this I made really, it depends. You can choose the infill percentage. So this is a drag-in that is 1% infill, which means it's hollow. And even though it's a little bit fragile, I don't have a problem just throwing it down. It's the same stuff Lego's made out of, so if you we've all stepped on a Lego. And so if you make it solid, it's actually quite usable for mechanical parts. Now, if you're going to make a blender out of it, and you're going to make the gears out of it, you can, but with any plastic gears, you're going to find that they're going to wear more than like metal gears. So you might want to take your plastic part and then make a mold and then pour metal into it if you wanted to make a blender that would last more than I don't know, 100 margaritas.
Okay, thank you.
Are there any more questions? No?
Thank you very much.
Thank you, Bree.